Now it's time to bring this sexy Commodore SX-64 back to life. Today we'll finish the restoration of this sexy Commodore SX-64 Executive Computer. In the first episode, we took a detailed look at disassembly. Then in the last episode, we restored the frame, power supply, floppy drive, and CRT. Now, I know the last episode was a while ago, but I've had a bit of a regression with the wrist issue. Took me a while to get a cortisone shot, but at least I'm finally in the I know I should be wearing the brace, but I keep forgetting it phase. Oh, and I almost hit the dog, and she's like, "What are you doing? What are you doing? Sorry, Tala." On top of that, I might have let this one get away from me a little bit. The project folder for the 3 episodes of the SX-64 is now over 350 gigs and climbing. Now it's time for the serious repair work. Now, from an earlier episode, we know that the SX-64 doesn't start, so we'll take a look at it and see if it's just something like a PLA or a more serious issue. Fortunately, the SX-64 has a beefy power supply, so it's unlikely to be a situation like with the machine that had over a dozen bad ICs where it's been plugged into a bad power supply and fried everything. There's only one way to find out, so let's take a look at the boards. Alright, so I'm going to show you real quick what I've done to be able to work on these boards. So, power supply is restored. I went ahead and pulled it out here, so then I can connect the power supply to the main board, and I just have the main board going here. Then I have the external video connected, which goes to the external video port, and then goes up into the 1702. So, turn that on, turn this on. And I have checked the board's getting 5 volts. And we have, as expected, a black screen. So to start off with, since everything's socketed and this machine's kind of a pain to try to work on, I'm going to go ahead and pull these chips off one at a time, deoxit the sockets, and then test them in the retro chip tester. It should test all of these. We've got the VIC, we've got the SID, we've got, looks like PLA, the ROMs, and the 6510, all lovely and socketed. So I'm going to do that right now, and we'll see what we get. After a quick test, I was surprised to find the PLA was good, as it's by far the most common cause of issues like this. The 6510 processor and all 3 ROMs also tested good. But then I found it. The VIC-2 is bad. Well, at least the SID tests good. So let's see what we got. We don't need the SID to run. We replaced the bad chip. So now for the moment of truth. Will it work? Come on. Oh, look at that. This looks like my new camera doesn't like the CRT, but it's looking pretty good. Of course, there's no flashing cursor without the CIAs installed. Okay, so bad VIC-2. Now, the I/O board here is a complete unknown, and I have to check these 6526s, the CIAs, which I'll do with the retro chip tester. Keep calling it that. It's really the back bit chip tester. I'll do that in a minute. The drive board's a complete unknown. No idea if it's going to work. So, progress. I'm going to check those CIAs. Passed. All right, one down. Again, passing test is no guarantee that it's good. There's certainly conditions where they can fail that the testers can't find. However, if you get a fail, you're pretty certain. I mean, a fail condition on these is pretty guaranteed it's bad. If you get, false fails are pretty rare. If you get a good test, it's still a really good indicator, but not a guarantee that it's going to be 100%. All right, that one passed too. So hopefully we got 2 good CIAs. Again, this machine is probably going to do better than most of mine because it is not from the Stone collection. It was stored under different conditions. I have no idea what those conditions were, but I very much doubt they were worse. Quick update on the PET. I do plan to get back to it soon and do the final 2 parts, the board restoration, showing it all running without being running on the Romulator, and then a episode that's a recap of all the repairs done, really brief, but with some history about the pet and education. I got some really cool images from the school district where this machine came from. Okay, all the socketed chips are tested, and fortunately this machine has a lot of socketed chips. Unfortunately, the VIC-2 failed. Fortunately, though, that seems to be the main issue with the main board. All right, in the future, when I do my next SX-64 restoration, I have a machine that was an old friend, so it's going to be my one I keep. But before that time, I'm going to order some parts. I need to get this connector, a couple other parts, and what I want to do is I'll make a jig. I'll have a power supply cable that'll go to these boards so that then these boards can run on the bench. Then I'll make up a monitor cable and a harness so that all of these can be just serviced on the bench without having to reinstall them all in the machine. Now, for this case, I think the best way to do this right now is reinstall them all in the machine. Once everything's back together, we can run the Diag cartridge and make sure that everything's good. I'm hopeful. There's, certainly a possibility that there could be bad RAM. There's lots of ICs on here that are not socketed, and the RAM is not MT RAM. Yay! So yeah, there's good reasonable hope that everything's good. So let's put it together and we'll see how it goes. Thank you to Backbit Tester Pro and the Retro Chip Tester Pro. Between the two of them, I was able to test every chip. This thing is awesome for the Commodore special chips. This thing I prefer for the way it handles EEPROMs. So kind of 6 1/2 dozen the other, I suppose. But if I had to just get one and I did Commodore stuff, I'd probably get the Backbit Tester. If I did other stuff, I might lean a little bit more towards the Retro Chip Tester, especially if you're not doing retro computers. Before reinstalling the boards, the VIC-2 needs its heatsink returned. I lost the footage, but the real trick was reinstalling it on the board where the clips on the heatsink need to fit into the gaps in the socket. Keep in mind that if you're replacing this socket, you will need one with a similar form factor. Returning the boards to the frame is as big a pain as taking them out. Start with the drive board, followed by the I/O board with the cartridge port, and finally the CPU board. Or, I/O board and CPU board order doesn't really matter too much. Getting those cables in there is a pain in the neck. Take your time and be sure that the wires are all routed properly, and be careful not to damage any while you do so. No, seriously, be very careful so you don't spend 2 days looking for a fault only to find out that the fault was your fault. I found that installing one of the inserts helped to stabilize the board position. Then all the wires can be reconnected and the zip ties replaced. Make sure the 2 pink wires from the front panel have enough slack to fit under the I/O board where it connects to the CPU board. Really careful when you're doing these two that have 2 connectors on them. The pink and red one coming from the board is for a reset for the floppy drive. This blue one coming from the power supply is 9 volts AC, so don't plug it into the wrong spot. That would be bad. So the drive has 1 pin that doesn't have a wire in it. That matches the gap. There is no piece in there to keep you from doing it backwards. Wish there was. I'm going to loop this under here just to control it. Keep it routed nicely. Also, while I was working with this plugged into the board, I went ahead and disconnected this 12 volts to the CRT because I didn't really want to be powering it up if I didn't need to be. So we'll reconnect that back up. That way the CRT has its juice again. When installing the I/O board, I discovered that I had neglected to clean the cartridge port, so after taking care of that, it all gets connected to the center header. In retrospect, it might be easier to connect this cable before returning the board to the case. Don't forget the plastic trim piece for the cartridge port. Now here's our 9-volt AC. Now let's route it through to here. Here's the main board. It's all looking pretty. The main CPU board goes in and fits into a slot in the bottom of the case. Once in, you'll want to pull the power supply back a bit to get access to the power connector. What a pain in the ass. Be careful while you have the power supply loose that you don't damage any of the short and delicate wires attached, or it may cost you. Now we can return all the retaining pins to the boards and make sure the wiring harness is fully connected. So I thought I was finished, and I mentioned to a buddy that I was done with it, and he said, "Did you do the I/O port and SRQ fix?" And I said, "Yeah, I did the I/O port fix." Yeah, what's the XRQ fix? So on P12, which is the keyboard connector, we need to connect pins 4 and 11 with a 3.3K pull-up resistor. And wouldn't you know, I got one left. So what I'll do is I'll pull out this last resistor and throw the bag in my pile of stuff to order so it remind me. And I'll grab a piece of heat shrink tubing. That should work right there. Just got to be as small as I can get it and have it still fit over the resistor. So now pin 4 is this one here with the 5 volts coming in, and pin 11 is a second to last, both on the top row. Then the resistor legs are bent to fit the distance between the pins on the connector and soldered in place with the heat shrink covering the exposed leads. That should do the trick. All right, so let's do a test. Have a moment of truth. See how we're doing here. I've got the harness and the diag cartridge. Since we're already coming up with a blue screen, we know that we don't have an issue where we need the dead test cartridge, so we'll just use the diag. It's also important to note that the internal serial cable connection between the I/O board and the drive controller needs to be unplugged for this test, as you can see here. If the internal serial connector to the drive is left connected, you'll get false errors from the diagnostic cartridge. When we plug in the parts, we're not going to need the keyboard or the cassette port. The keyboard is different on the SX-64 and there is no cassette port. The diag should automatically detect that and work accordingly. So give it a test. And in 3, 2, 1. Okay. And the test is running. I spent something like 2 to 3 days trying to figure out why I kept having the 6526s in serial port coming out as bad. I went down several rabbit holes, including checking the diag cartridge and harness compatibility, trying different CIAs, checking the I/O board for issues, even trying a different I/O board, re-cleaning and applying deoxit to the rear connectors, making sure I had the correct cable disconnected, testing with the keyboard connected, and much more. And then I found it. Well, I think I finally found the problem with the CIA's testing is bad and the serial port. And hiding underneath here was a loose wire, and that is entirely my fault. So let's get that soldered back in. All right, good test. I didn't like the sound of the white noise, but we'll see how that sounds when it's properly connected up. So, but we are running diagnostics, and I am going to let this run for a while. I will turn the cameras off and then turn them back on in a little bit to see where we're at. All right, test number 65. So it's looking good. So the last thing to deal with, got sound here. Yeah, that's all the way up. No sound coming from the speakers, so it is connected. So let's pull that out and see what's going on. The SX-64 uses a separate amplifier that's part of the CRT to drive the internal speaker. And since I have good sound on the external monitor, I believe that the SID and the CPU board are working fine, so I'm going to start out by testing the speaker itself. To get easier access to the CRT, I pulled the power supply back a bit, then removed the 3 screws. There's the speaker. Everything looks all right. Wires are all connected, so we'll check the continuity. We should have, I believe, 8 ohms. And looks like we have nothing, just an open loop. Just going to gently see if these are disconnected. That's fine. Oh, those are connected. Oh, that sucks. So basically what it sounds like is the coil inside the speaker has separated. Did clean the speaker a little bit, but I was very gentle and very careful with it, so I'm not sure what I could have done. I have a feeling it was bad to start with. So I'm going to pull the speaker out of the parts machine and then we'll take a look at that. Here is the replacement speaker. Let's see what we got here. Now look at that, 16 ohms and a beep. So that is indeed the problem. So after replacing the speaker, we still have no sound. What? It then occurred to me that perhaps the internal sound is locked out when an external monitor is connected, but a quick test verified that there was still no sound. Well, After double checking all the wiring, it occurred to me that a fault on the board might have fried the replacement speaker. Please don't be blowing speakers. Okay, speaker's still good. What a relief. I don't have another spare speaker. I was fairly certain that the issue lies with the audio driver circuit in the CRT. So, to narrow down my troubleshooting, I returned the speaker to the part CRT and hooked it up for a test. Alright, so that answers that question. Been a long day, I'm tired. Tired, I tell you, tired. Normally I'd start tracing signals with a scope at this point, but I was really tired after a very long day, and the spare CRT was handy and I was kind of curious how well it worked. I'm also a little reluctant to use my scope in a CRT or on a switching power supply because I know that it's possible to connect it incorrectly and fry the thing. This isn't a necessary troubleshooting step, but at the time it was necessary for my mental health so I would know where I was at before I went to bed. I sleep better that way. The next day I set to testing the components in the audio part of the CRT board. I noticed that the capacitor I replaced earlier was part of this circuit, so I suspected there were other issues. After checking a dozen or more parts, I found a resistor that read 680 ohms instead of the rated 1K. 609 should be 1K. 609 is a baby one. This is not unusual in checking parts in circuit, as there could be another part in parallel with the resistor leading to a low reading, so the only way to be sure was to remove the resistor from the board. Board's a little bit of a pain in the neck to solder on because it's still soldered to several wires that go to the CRT. And I do not believe that is going to fix this. But it's a start. And I couldn't find anybody who had seen that size resistor in there. This little tiny 680 ohm instead of a 1K that belongs there. If a part is easily accessible, you can just disconnect one leg and test it that way. But in this case, it's a tiny little 1/8 watt resistor that is buried in a bunch of parts. After removing the resistor, I still found that it measured 680 ohms. And then I noticed the color codes on it. It's a 680 ohm resistor, so that explains it. I know Commodore sometimes used whatever was on hand when they ran out of parts, and nothing looked like it was previously reworked, so I went ahead and replaced it with a 1K resistor and gave it a quick test. Hey, there we go! Oh, man! This thing has been a beast. I still think the SID's not great, but other than that, the bad is just because I don't have any of the harness in the back. So now I'm going to turn off the cameras and put everything back together and see where we're at. Now, I'd like to say this is another story of Commodore cheaping out and swapping in a substitute part, causing damage to the machine, but I really don't see how that's possible. Looking at the schematic, you can see that the resistor in question is on pin 6 of an AN5250 TV audio IC, and both the schematic, where it goes to the front panel, and the data sheet clearly show this is just some additional resistance on the volume control circuit, so the machine would have been very slightly louder than normal, but it shouldn't do any damage or be enough volume to blow the speaker if someone had turned it up all the way. I hate situations where I don't know exactly what I did to get my result. But in this case, I just don't see how that resistor could be the cause of not having sound after I replaced the speaker. I suspect that when I installed the speaker, it was making poor contact and that it just wasn't getting a good signal. So just to be sure, I went ahead and added a little bit of deoxit to the connector. Now, I know that the keyboards on the SX-64 can be a source of a large number of problems, and I do have a spare membrane on hand just in case, but when I turned it on, and I did this earlier, but I didn't get good footage of it, so yeah, I was shocked too. The keyboard's working very well. It was a little bit oversensitive at first. It wasn't the keys didn't work, it's that I'd occasionally get a double or a triple hit on the key. But after a little bit of working with it, it settled in and it's working very nicely now. If I have problems in the future with it, I'll have to take the membrane off and clean all of the pads. But that's a pretty risky repair, so I'd rather not if I don't have to. So I figure next, let's give it a test with the current build of Dark Dominion of Maldrakar, the RPG I'm making. And I started in 1984, 83, somewhere in there. This is the November 2024 build of DDM that I'm using to test keyboard function. I'm currently working on a couple DDM update videos, so the sharp-eyed may see more than a couple new features since the last update. Those videos should be out really soon. No, really. This is the first time I've run DDM on native hardware in a couple of months, so I was pleased to find no issues. That's a testament to the creators of the Vice emulator, Kick Assembler, and the Visual Studio Code plugin for it. I don't have any nice video captures since somebody accidentally snagged my cable and ripped out a bunch of wires, but I have a nice shielded S-video cable I'm going to use to make a replacement. Alright, so let's give it a final test with a little bit of Moon Patrol. And definitely I think this SID is marginal. It's good enough for me, but if I sell this machine, I'll have to swap it out with a different one, I think. There you go. Seems to work better than I do. Okay, and there we go, running the November 2024 edition of Dark Dominion Amaldricar, running on native. That gets me so excited. But if you're looking for the document on how to take the SX-64 apart, you'll find that in the description below. Over the next couple of weeks, I've got some more things to add to it, but I'll update it as I go. I hope you enjoyed this series on the SX-64. If you didn't see it, part 1's right here, and thanks for coming.